Hi guys, in the previous video we had seen the difference between mean and standard deviation. In this we will look at their limitations. We have to import this library and then this function we used in the earlier video. We are going to make use of it again. So we are creating three data sets. X is 1 to 10 with a jump of 1. X1 is plus 30. That means 31 to 40. Again, the jump is only 1, 31, 32. And X2 is X plus 80. That means 81, 82. Again, a jump of 1. Now, we will draw three graphs for each of these data sets. Look here. This is about X 1 to 10. Mean is 5.5. And since we change the values, now it is 31 to 40. Mean is going to reflect the average of these numbers. So now it is 35.5. It gets increased further. Now 81 to 90. Now mean is going to give us the average or mean of these numbers. That is 85.5. So what mean is doing? Mean is going with the character of this data set, right? As the data set is having more values, mean is reflecting the magnitude of the values. So here it is 5.5, here it is 35.5, and here it is 85.5. Look at the standard deviation. Look, here it is standard deviation, that blue dashed line. Same here, same here. Data set is moving away from here. It has moved further away from here. But standard deviation is not budging from its earlier position. We know why. The reason being the dispersion over here is same. What is here and here? There is only a jump of 1. So the distance between 1 and 2 is equivalent to the distance between 31 and 32 and 81 and 82 and so on so forth, right? Hence, standard deviation will not go away from here. It will be here only. That is 2.8723. Superficially, if we look at these graphs, it looks as if mean is very smart. It is going with the character of the data set, whereas standard deviation appears to be stubborn. But this is not the limitation of standard deviation. Standard deviation is doing its job. It is only concentrating on the proximity of each and every element from the mean of the data set. Since the proximity of each and every element from the mean of this data set is exactly same everywhere, standard deviation continues to be 2.8723. But what does mean do? We have already seen here, right? Mean combines every unit and then divides the combined result by the number of units involved. So that is precisely what it is doing. And hence, mean is jumping from here to here and then here to here to reflect the average of this data set and then this data set and then this data set. If at all mean looks smarter than standard deviation, then let us discuss about these data sets. See here what is happening. X is 40, 40, 40. There are 10 40s. Okay. And Look at this graph of this x. All are 40s. Average or mean will be 40. Since there is no gap between any of these numbers, every single number is 40, standard deviation is 0. Why? Because there is no dispersion. Dispersion is 0. No distance between any two numbers. All numbers are same. So this mean is 40, standard deviation is 0. Look at x1 now. Here 38, 40, 42, 36, 44, 50, 30, 20, 65, 35. Here proximity is not as tight as it was here. Here every number was same. So here dispersion is there, right? Now when we see x1, now this is wrong, we should say x1 here. Okay, let me change this. Uh, this should be okay because of this. Okay, okay, no problem. Let that be there. So here this x1 is this, mean is 40. X2 again, mean is 40. See now this time mean appears to be stubborn. Look, 40, 40, 40. Now what does mean do here? It is summing up all these numbers, dividing by 10. It is getting 40. It is summing up all these numbers, dividing by 10. It again got 40. Again it has done the same thing. It got 40. So 40, 40, 40. So no matter what the numbers are, mean is not changing its position. It remains at the same location. But what about standard deviation? Here it is 0 for this data set. For this data set, 11.3578. Look here. And here, see, here dispersion is too much, and that dispersion is getting reflected by standard deviation. It is 33.5946. Look. So now, so far as these data sets are concerned, standard deviation looks smarter as compared to mean. Just the opposite of here. Here mean was jumping here and there with the data sets, and standard deviation was not budging from its position because every single data set's proximity was same. Here standard deviation is jumping as we are tinkering with the proximity of the data sets. Hence it is reflecting that. But we are changing each and every data set, but we have not changed its mean. We are writing values in such a way that we are getting mean again and again 40. So this, right? Now it is very clear that what mean is going to do, standard deviation is not going to do. And what standard deviation is going to do, mean is not going to do. Mean will be telling us, look, I will take all the values from a data set and I will calculate the average and I will give you. So magnitude of the values matter a lot when it comes to mean. But so far as standard deviation is concerned, it doesn't really care about magnitude, whether number is in single digit, double digit, or whether the numbers are in millions. It doesn't care about the magnitude. It only cares about the proximity. How far the values are away from the data set's mean or average. That is what is going to be reflected by standard deviation. Okay. Now, having seen these two types of data sets and drawn these graphs and discuss about standard deviation and mean, we have seen the differences, we have seen the limitations. That begs a question as to which one we should use more frequently. The answer is simple. Both are equally important. In fact, they do complement each other. Although we are quite familiar with mean and use it extensively in our daily life. But when it comes to dealing with a large data set, we should use standard deviation in conjunction with mean to get an instant insight into the data set. See, we can easily calculate mean. We are quite comfortable when it comes to calculating mean or average. But having appreciated the importance of standard deviation, we should get equally conversant with the calculation of standard deviation as well. So, next thing that what we will do is we will learn how to calculate standard deviation. We have already appreciated the importance of standard deviation. It is a very close friend of mean or average. Okay, it does help us get an instant insight into a data set if we use standard deviation in conjunction with mean. Correct? So let us calculate standard deviation. So this is the data set we are going to see. 1 to 10 number we will generate. There are 4 numbers only we are going to generate. Okay, not big anything more than that. That is not needed for building the concept. So 4917. How we can calculate mean? Simple, right? Sum these numbers and divide by the number of these numbers. So 4 is the number of numbers and sum, whatever sum comes, this is what 13, 14 and 7, that is 21. So 21 is the sum. Yes, then we will divide by length of x, that is 4. We will get 5.25. Should we calculate like this? Never. We we will have a lot of functions available with us. We can make use of them. So here we are using numpy's mean and we are getting 5.25. Correct? It is quite simple stuff. Now let us calculate standard deviation. So before we calculate standard deviation, we should calculate variance. What is the formula of variance? This is the formula of variance so far as population is concerned. Now, what is this population? Population means the entire data set. A data set may have 5 values, it can have 50 values, it can have 5 million values, it can have 5 billion values. When we are considering all the values and if we are calculating variance or standard deviation for all the values, all the units, then this formula will be applicable. We are not talking about subset of data set. We are talking about entire set of data set. Okay. So let us see what this variance is. Okay. Now variance calculation. This is the formula. Now this is precisely what we are going to do over here. See, what we are doing is we are creating a data frame. Okay. See, we are creating a data frame. Let me do it all over again. We are creating a data frame for that X like this. Okay. Let me make a room for this. We will discuss again. We will remove once we have completed our discussion on these three lines. So 4917. Okay, we are naming it. We know how to name. Now this is column is called X. We are putting it and calling it DF, that is data frame. Done. Next, what we are doing? Look, we are calculating here what we are doing. D of X minus NP mean. What is this? Each and every unit of data frame, each and every unit of data frame is getting subtracted by its mean. What is the mean? Mean is 5.25. So we will get 4 minus 5.25, 9 minus 5.25, 1 minus 5.25, 7 minus 5.25, right? So what we'll get? Let us see. 1.25, 3.75, 4. Okay, 25 and 1.7. These numbers are in negative. 2 are in positive, 2 are in negative. Okay, that is fine. Then these are the numbers we are going to square. The question is why we have to square it? Look, if we take the total of this, it will become 0. Let us take the total of this. D of X underscore mean, it will be 0. Always it will be 0. Look, any of these numbers, if it happens to be equal to mean, then mean minus that number will be 0. Or we are taking mean, some numbers will be more than mean, some number will be less than mean. All the numbers which are more than mean will offset the numbers which are less than mean. So we will always get 0. So we have to get rid of this 0. So what we are doing to get rid of 0 is, next step, we are simply squaring each and every number. That will make this minus sign disappear. That minus minus will become plus. But it will pose another problem. The number will get inflated. Correct? 4 will become 16. 2 will become 4. Like that. So anyway, we have to do that. Let us do and we'll discuss further. Now let us check this data frame, how it looks. Now this is the data frame. This is how it looks. Now what we will do? Before we do, let us visit this. We have considered X here and we are saying minus mean. Yes, we have done, we got all these things. And then this has to be squared. The result has to be squared. That is precisely what we are doing. We got this result and we have squared this result. This is what it is. So we have taken care of these p's. Now we have to sum, which we will have, what we have to sum? We will sum df x2. We have to sum this. Okay, we have done that. Okay, so numerator part is over. Divide by n, that is number of numbers. So what we will do? We will say, look, go and divide it by the number of number, that is df, 4, right? What we get? 9.1875. And what is that? Sigma square. This is nothing but variance. This is variance. And we will take square root of that number, that will give us standard deviation. This is the formula of variance. Once we take square root of this number, we'll get a standard. Why are we doing a square root? Look, variance is basically an inflated figure, isn't it? Why? Because this 4, I mean, all the numbers are getting squared. It is just going up. So we are summing up. When we summed up, we got which figure? 9.18. it is an inflated figure. By using a square root, we are sort of bringing back to its original unit, assuming that 4 user unit. If you square it, it becomes 16. So if 4 unit is, assuming that it is unit of measure is meter, 16, what happened? It has become square meter. If it is kilometer, it is becoming square kilometer. So that is again, we are bringing all the units to its original unit of measure, right? So what we will do now, this entire thing, we can say NP square root, and look, this time we will get 3.031, and this is what is standard deviation. Before this, whatever we got, that was variance. So let us keep all the things. It is already there. Let me delete all of them, and we have all the calculation already done. So let me remove them. Okay, this is there. Okay, fine. So this, let me remove this as well. This as well. Now, when we do this, what we will get? We will get variance. See, this is a calculation of variance. This is variance. How we will get standard deviation? This number, square root of this number. So square root and the same stuff we will keep. We will get standard deviation. We could have even done like this, right? We can write var and then say this is var. That is nothing but variance. And then we can simplify it, right? It will look much better. We will say take square root of variance. It gives us standard deviation. Done. Let us recap what we have done. We have done all the calculation according to this formula. We got variance. And when we use square root of this variance, we will get standard deviation. Okay. Can we use it little differently? Yes, we can do that. Just see. We will say NP mean X. What it is? This. Then I say minus X. What it will give? It will give all these values, right? Good. After that, what we have to do? We have to square all the number, right? We will get this. Good. Then what we will do? We will use summation we are doing. We did summation. Okay. Then we will divide it by 4. That is length of X, count of X. That is 4. We are getting what we are going to get now. We will get, see, we got variance. Then what we will do? We will say square root. You got the standard deviation. Correct? So we can also do like this. Here I will remove this square root. I will just keep it like this and there, and then this is my variance, this is my standard deviation. So we can use like this as well. We create a data frame. We have used this syntax to get variance and standard deviation, but there is absolutely no need to reinvent the wheel. We already have all these things. We have mean. Yes, mean is available. We have variance available. 9.18, just see, we calculated. We also have standard deviation. So we will use them. We will never calculate. But what exactly we are doing? We are only trying to understand how variance and standard deviation are calculated. In fact, we calculated average also, mean also. Now, there is a shortcut to doing this. Okay. This is the formula for variance, right? Now, this particular thing is being simplified and we are getting this. See, sum of x square divided by n minus mu square. This will give us variance. This will also give us variance. I mean, so what we can do is forget about this formula, it involves too many data, we will use this. So we did not subtract each and every individual numbers from mean and then square it, then it sum all of them and do all those stuff. We can simply use this formula. See what we are doing here? Look, we are writing d of x square is square, right? This piece, this piece, okay? Sum it. Done. Then what it is saying? Divide by n. Divide by n means what? Ln x or df, whatever, 4, right? Then what is saying? We will say minus, and then what? Mean square, that is mu square. So we'll say take mean of x and then square it. Enter it. What we are going to get? Again 9.1875. So this time we are deploying this formula. Correct? This has already been done here. And what will happen? This is my variance. How will I get standard deviation? You will get standard deviation by writing square root. Got it? So what we are doing inside this function? Calculating variance, putting in this variable called var and return var, comma, np square root of var. So what we will go? We will get, now we will pass x, get var std, this function we are invoking. We'll get variance and we will get standard deviation. So let me remove this. This we have already discussed. Okay. So this is how we can calculate standard deviation. We have to get variance and then only we can calculate standard deviation. Only one step. Whatever variance we are getting, we will take square root of that variance, that gives us standard deviation. Simple. So what we have discussed, let us recap the entire thing. We discussed the difference between mean and standard deviation. This we covered in the earlier video itself. Today, in this video, we saw what standard deviation is doing that mean is not doing, and what mean is doing that standard deviation is not doing. And we concluded that, look, if we want an accurate, perfect insight into our data set, and that too instant insight, we should use mean as well as standard deviation. Having appreciated the need and importance of standard deviation, we have also seen how we can calculate standard deviation. And we use three different ways of calculating. We use this, we created data frame, then we use, so when we created data frame and numpy stuff, this line, we use this formula. But this particular thing is derived from this particular formula, this, and then we use this to again calculate standard deviation and variance. I hope now the concept of mean and standard deviation and also how to calculate variance in the standard deviation is clear. Thanks for watching, and I will see you in the next video. Deploying this formula. Correct? This has already been done here. And what will happen? This is my variance. How will I get standard deviation? You will get standard deviation by writing square root. Got it? So what we are doing inside this function? Calculating variance, putting in this variable called var and return var, comma, np square root of var. So what we will go? We will get, now we will pass x, get var std, this function we are invoking. We'll get variance and we will get standard deviation. So let me remove this. This we have already discussed. Okay. So this is how we can calculate standard deviation. We have to get variance and then only we can calculate standard deviation. Only one step. Whatever variance we are getting, we will take square root of that variance. That gives us standard deviation. Simple. So what we have discussed, let us recap the entire thing. We discussed the difference between mean and standard deviation. This we covered in the earlier video itself. Today, in this video, we saw what standard deviation is doing that mean is not doing, and what mean is doing that standard deviation is not doing. And we concluded that, look, if we want an accurate, perfect insight into our data set, and that too instant insight, we should use mean as well as standard deviation. Having appreciated the need and importance of standard deviation, we have also seen how we can calculate standard deviation. And we use three different ways of calculating. We use this, we created data frame, then we use, so when we created data frame and numpy stuff, this line, we use this formula. But this particular thing is derived from this particular formula, this, and then we use this to again calculate standard deviation and variance. I hope now the concept of mean and standard deviation, and also how to calculate variance in the standard deviation, is clear. Thanks for watching, and I will see you in the next video.